Hello everyone and welcome to my presentation about RxJS operators. RxJS stands for Reactive Extensions for JavaScript, and it's a library that enables asynchronous programming. An intrinsic part of RxJS are its operators, and these are essentially functions that mainly do two things: either create an observable or accept an observable as an argument and return another observable, which is a new one, so pure functions which have immutability of the source operand. What are we going to talk about today? Of course, operators. So there are more than 100 of them. I will try to give a comprehensive overview of all of those, and afterwards there will be like use case of 2 mini games where some of operators will be conveniently missing, and we will try to fill them in. I wouldn't like this to be like a one-way presentation where I talk for 1 hour straight, so I would also like some interaction with the audience. And before that, I would like to see how many of you are experienced or familiar with RxJS. Okay, good. Then looking forward to the questions. Before we start, a couple of words about me. So my name is Blagoj Jovanov. I came here from Macedonia. I work at Swiss company in etc. And this rather long job title wants to say that I have several years of experience in applications revolving around a protocol which enables increased security during online payments. The easiest way to describe me is via 3 things that I love doing, and that is traveling, running, and last but not least, coding. So now we can start. The first group, as I mentioned, are creation operators. And whenever we think of some asynchronous call, we say, okay, we have HTTP client, which under the hood does an AJAX call to a server. And this is like our first operator. So we have AJAX, which basically accepts one object, and there we define like the target URL, the method, headers, and body if applicable. In this case, because it's a post method, it has a body. And because we send to this http-bin.org, what this does is basically it replaces the request body into the response. And here, as we see, like we have a valid response. Next operator, we want to compare like generate versus range. So first, generate is more flexible operator in the meaning that it accepts a couple of arguments. As we see here, first we need to define the initial state, then the stopping condition, the iteration increment, and the result selector. This is like the easiest way to do it, like with numbers, but of course it accepts also arbitrary objects. But in most of the cases, we do not need to use all of this, but we rather want to iterate like incrementally from one point to another, and that's why this range operator is like a special case of the generate, where the upper is basically the same rewritten with range as a result. Sometimes we want actually to have emission of values delayed or certain intervals. That's why we have another 2 operators. This is like timer and interval. There is a slight difference between these 2. So for example, here we have the usage of a timer, and here we have the usage of interval. The thing is that if you use interval, always have in mind that this emits on a trailing edge, so there is no immediate emission. First, this time needs to pass, and then the emission happens. So if you would like to emit like immediately and then after every n milliseconds, you would use the timer, because the first argument is the initial delay and the second one is the same as the interval, so it will emit like every n milliseconds. Other operators will compare like from and off. So these are like mostly used. Basically from one object you have observable which emits that object. And the easiest way to do it is via comparing arrays, because that's like the main difference. So from operator would accept observable, promise, or iterable like. The same case with the off, but here from would actually emit the values one by one, while off doesn't do any processing. So if we supply array to it, it will emit it as a whole. Another thing to mention is, because I mentioned that from is accepting iterable. So for example, if we want to emit object, we cannot use from, and we need to use off for that one. So this is also an important difference. Next, also sometime we are interested in emitting some objects from the DOM. So we have like, again, comparison of 2 operators. The first one is from event. This is like mostly used because there we have like document and then all of the natively supported events on the DOM. On the other hand, we have this from event pattern. So this is like, again, something more flexible. it accepts like a random API for registering or deregistering of event listeners. So again, these two are equivalent, and in most of the cases, this add event listener and remove event listener would do. But if we have some custom API, we are also able to use the from event pattern. Then we have a group of transformation operators. So the most used of this is the ordinary map. So we have some kind of object, then we apply the map operator to this, and we return a different type of object. In many of the cases, what we would do in map is like we have one object and then we take one property of it, and that's why there is like a separate operator called pluck, which does exactly what we would want. And now for a warm-up, we have like some example. So we have 3 same nested objects, but we are applying like the map, map2, and pluck operator. So let's start with the first one. If we have a map, what would you expect this object.value to return? If we have this object. Yes, that's correct. Then the next one is map2. I didn't mention it, but what would common sense tell to you that you expect as a result? If you see it doesn't like accept any input argument. It would return, it would return a constant. And the last one is pluck. So here we supply basically the path, value, and v2 of a nested object. So we would expect that it returns. Yes. But if you see, for example, this is not that type safe. So what would happen if instead of value, I would put foo here? Yes, so this is important because also another nice assumption would be to fail, because you have like something undefined into the path, but under the hood pluck uses this safe navigation or optional chaining operator, like these question marks with a dot, and it ensures that if we have invalid path, it wouldn't crash at least. Okay, so this is like the easiest thing when we have map and we have ordinary values. But what happens now if we have an observable which emits values which are observables themselves? So we're talking now about a higher order observable, and the thing is that if we need to subscribe to this, we would need like 2 subscriptions, because one is when we subscribe to the outer observable, we get the value, but because this is also an observable, we need to subscribe twice. And this could easily lead to a messy code, and that's why we have some operators which actually under the hood subscribe to the inner observable, and then we are left with only 1 subscriptions. There are like 4 of them. And I will compare them by looking at one scenario. So we have 2 observables, and the scenario is like this. We have the outer observable, which emits 1 value, and then the inner observable emits again values based on that value from the outer observable. And now the question is, while the inner observable hasn't completed, there is like another value coming from the outer observable. And now what happens is what distincts these 4 operators. And first we start with the concat map. So it's not very intuitive, but what concat map does, it respects the order of emission. So this means that you cannot emit values from subsequent observables until the previous ones complete. How concat map does this is that basically if another value comes from the outer observable, it will buffer it internally. It will wait for the previous one to finish, and then it will emit all of the values. And that way ensures that basically all of the observables are concatenated and always the previous one finishes, completes, before the next one starts. However, in some cases, we might not be interested in that. We would just like that if some value comes in between, we emit it immediately. And that's what the merge map operator is. So here it again subscribes to all of the values, but instead of buffering, it just waits for a value, and once it comes, it just propagates it to the output, so it is immediately visible. However, in some cases, for example, when you do a search and there is like a type ahead and you wouldn't like the previous observable to complete, you like this to be switched immediately, you would use this switch map operator. So again, if we have the same question, what happens on a switch map if some new value comes? Then in this case, it doesn't wait for the previous one, it cancels the subscription, and instead switches to the new observable. But in some case, although this is like the least used operator, we would like to do the opposite thing. So when a new value comes, we would like actually to ignore it and wait for the previous observable to complete. And this is what the exhaust map does. So unlike switch, it keeps the previous one, but unlike concat map, it doesn't buffer the values, but rather if something comes in between while the previous one emits, it simply discards it. And now let's make a mental map of this 4 based on this simple decision tree. So let's start at the beginning. We have a distinction by single subscription. So if we need to define this, which would go on the left side, which would go on the right side. Any guesses? I mean, I didn't say this explicitly, but the thing is that how many operators have like single subscription at a time, and how many of those subscribe to all of the values? Well, basically the single subscription is for the switch map and the exhaust map. Because as we said, the switch map, once another comes, it replaces it. And the exhaust map, once another comes, discards it. So it's always one at a time. So these two would go on the left side. And now the question is, if we have switch map and exhaust map, if we compare based on the new inner observable precedence, which will go into the yes branch and which one into the no? Switch would go in the yes, and okay, and exhaust map in the no. And now on the right hand side, if we take a look at the concurrency, we have left the merge map and the concat map. So which one supports like concurrent emissions or out of order emissions? So which one supports concurrent emissions? Yes. And the concat map is basically like merge map with concurrency set to 1. And here we have it. Next, of course, here we're talking about 2 operators. Now the more the merrier. We come with n operators, and sometimes we need to look at all of the values at once. That's why we have these joint creator operators. And can you maybe guess like what's the name of this one? Because I'm aiming for pictures, whether it's like intuitive enough. What would be the name of this operator? Fork join will be later at the presentation. There will be a more explicit picture about that. Yes, well, which city is this one? I mean, I took the first one that was from Google. or it's hard to guess. Well, this is supposed to be LA, I mean. So this is like combining latest. So this is an operator which basically takes n observables, and whenever each one of those emits, then it takes all of the values as iterable and displays. This is the case when all the observables are more or less equal, but sometimes we want one observable to be more equal than the others, and we want, when this one emits, to actually take the latest values from the other observables. And this is like, okay, one intuitively named operator, and this is like with latest from. And now what someone mentioned is like this fork join operator. So this is like a good interview question. For example, how or whether it is possible to do promise all with observables. Having in mind that we assume, for example, we have observables with emit only once. Can we use some operator to actually exhibit the same behavior? And we can do. The thing is that if the observable emits only once, we can use either the fork join or the combine latest. Because the catch is that with both combine latest and latest from, we need all of the observables to emit at least once in order to get the result. This is like a common mistake. And if we say that the observables emit exactly once, this is the same as promise all. So then what would be the difference between combine latest and fork join? The difference is that fork join basically waits for all of the observables to complete, and then it emits like the latest value from them. So in case the observables emit many times, then fork join will just emit at the very end. But there are some cases into which we want actually to have a group of observables, and then we wait that each one of those emits in sequence, and then we group these results. It's a bit hard to understand with words, so I will give an example. For example, we need to measure some kind of a duration, and then we need like both of the start time and end time to be present in order to calculate the difference. And in this case, the zip operator would be in handy because it will wait like for emissions of both observables, and then we will have these values and we can do whatever computation we want. The last in this group, which basically doesn't have much things in common with the other ones, the only thing in common is that it uses like multiple observables, is the race. So what the race does is that it subscribes to n observables, it waits for the first one to emit, and then it just emits values from that one, the other ones are discarded. And now again, the question is, if we want to display this on a frequency axis, and we have here the emission frequency, so let's start with the easier part. Which of these 5 operators would be at the very extremes? So as a reminder, we have like this combine latest with latest from, fork join, zip, and race. And which one of these theoretically should emit the least and which one should emit the most? Are you sure? Exactly, because it emits whenever any of the observables emit, so that's correct. And about the least emissions? No, race waits for the fastest observable, and then it actually emits all the values from it. Someone is saying it, but not too loud, in a bit shy way.
It's fork, isn't it?
Yes, it's fork join because there we emit like only once. Once all of the observables complete, you take the latest value. So this is the easy part. And then in the middle, I mean, it could be like any order, because this is like very case by case. We have with latest from, and this will emit based on the observable that is source. So how many times this emits, we'll have those number of emissions at the end. In the race case, we have like the number of emissions of the ones which is the fastest observable. And into the zip case, zip actually stops emitting once one of the observables complete. So again, this would mean that it will emit by the number of times the shortest observable has. And because these are like really subjective, I just put them here, but the order could be arbitrary depending on cases. Another very common operation that we do with operators is like filtering data. So we have like filter, which is like the most obvious one. We have partition, and we have group by. So here I have some examples. The first one, for example, with the filter is the very easy one. So it accepts a predicate, and basically it returns the elements that will pass the predicate. Sometimes we're interested in actually to form like 2 groups, the ones that passed the predicate and the ones that didn't, and that's why we could use the partition operator. So for now, please ignore like these warnings. There is a reason why StackBlitz is confused, and also this deprecation. We'll come back at it later. The main idea of the partition operator is that, again, we give it a predicate, but the result is an array. The first argument of the array will be the ones that passed the predicate, and the second one, the ones that did not. In some cases, if we want to further advance this and create like multiple groups based on criteria, we can use the group by operator. And here again, we pass the predicate, but then we would like actually to have a list. And in this case, we'll use reduce. So once all of these elements are processed, they will be grouped, and there will be like n groups outputted as the result of that one. But if you see here, for example, partition also displays the key. And into the group by, we will have the groups, but it will not be clear what is the key for those. That's why we can use some other operators. In this case, to array. This basically first processes, and then once it completes, it emits as array. But the most important thing here is that on the group observable, we have the key property, and this is how we can get a hold of it and display, so that it is easier by which argument we group by. And now we have also transformation operators, which are scan, reduce, and expand. If we use scan, it's important to notice that every time an operation is performed, there will be an emission. So scan accepts two arguments. The first one is now like an accumulator, and then like a function what is going to be. And the second one is the initial seed. So what this does, it will just sum up the numbers from 1 to 10, but emit on every summing. Usually this is not what we want, but we would rather just want the final result. And in this case, we would use the reduce operator. So the only difference is that it will emit once everything is finished. On the other hand, we had expand operator, and this is a recursion. So this example here is like really contrived. Again, I'm trying to make some equivalence between the previous examples. I would like here to focus on how to stop the recursion. So there are like two ways. The first one is to use the take operator. And this would mean that once the 10th recursive call is made, this will end. Or the second one, which is like more common, is that we define the stop condition. So here, once we have the arguments, we can define like some logical predicate. And after this is fulfilled, we'll return this empty, which is like specific value. And this again will terminate the recursion. But anyhow, there aren't like much use cases when you would use like an expand operator. And then again, we go back to the comparison. So we have buffer and window. So these are two operators which basically enable some grouping before we emit. So we saw examples where we emit like on every computation. We saw we emit only once, and now we need to see like we emit like a couple of them or some. And here I have a basic example where we are tracking the click events. And now we have like, again, different flavors. Here it's the buffer, but the window is the same, except that buffer returns an array, window returns an observable. So the most common use case is that we buffer until some observable emits. So in this case, the interval will emit the number starting from 0 incrementally, and it will emit an array once we click somewhere on the document. Some alternatives to this is, of course, if we do not use an observable, but just a number, and this will say once we reach 4 arguments in the buffer, we emit, or once 4 seconds pass, we emit. And these other two are less common. So buffer when basically accepts like a closing selector, and then it can be a complex logic. So when the buffer is closed, and this buffer toggle is something like, again, more flexible buffer when, because except of a closing selector, it also has like a observable object for the opening ones. Buffer when would open immediately, and buffer toggle will explicitly say when it is open and when it is closed, and after that the emission would happen. Also, I didn't mention is that buffer count would accept like a second argument. If you do not supply it, this would mean like we have 4 elements, we emit those, and then we move on to the next 4. But we can allow overlapping if we define the second argument, and this would mean like, okay, the buffer will open after n elements. And in this case, this buffer count would basically emit like all the subsequent pairs. And this is like quite common, and that's why there is like a dedicated operator for that one, and it is pairwise. So this buffer count to 1 and pairwise are basically the same thing. Now we have also filtering operators based on time. So again, there are a couple of flavors of them. So we have audit time, sample time, throttle, debounce time, and delay. How would we compare this? Audit time is basically like starting a timer, and then, for example, here we have 2 seconds into which some of the values are emitted. What this does is that after 2 seconds pass, it will take the last emitted value, and that one will be emitted. The other ones are discarded. Opposite to that one, we have throttle time, at least for the default configuration, because here you can define like whether to take the leading or the trailing value. The default is leading, so this would mean that after 2 seconds pass, it will just take the first value which comes in between. You could change this one if you set trailing to false and leading to true, then this will be the same as audit time. But with one important difference is that audit time will not emit the last value if the observable completes before this delay is done. We have left with 3 things. The first one is sample time, and this is like the most simple one, because this just says, okay, after 2 seconds, take me the last value. The bounce time is used, for example, mainly in searches. So previously I mentioned we have a switch map, but also the bounce time is good because when you type in, you wouldn't like to have like the requests on every millisecond, but rather first wait for some time, and if there are no emissions in that time, only then emit. So it's quite convenient. And the last one is delay, and delay just delays the emission by the number of milliseconds passed as an argument. So now again, we would like to see how we could remember this. So we have this familiar marble diagram, and here we have the source, and then 5 lines which you would need to complete with the operators that we saw on the previous slide. And let's start, for example, with the easiest one, the one at the bottom. So again, a reminder, we have like throttle time, debounce time, audit time. Those are the operators that we have. Which one would be at the bottom? Because as we see here, it's sequenced like on every 100 milliseconds. No. Because this one would take also, it would take into account whether it is like the first one or the last one. And this is just doesn't care about it, it just takes the value that is emitted after a given interval. No, because throttle and audit are really connected. As we saw here, it's just a matter of whether to configure the leading or the trailing. So we're left with the bounce and sample. If you look grammatically, which one of these would make sense? Yeah, it would be sample because it just takes like the value which is emitted into after 100 milliseconds. So after we ruled this, the last one, let's see now about the two above those. As we see here, these two are very similar, except for this one in the middle, which also has one value at the end. So what did we say now about which two operators are connected via configuration? Come again? Yes, it's audit and throttle. The only thing is like which configuration do we need for throttle in order for it to match with audit? Whether it will be on the leading or on the trailing edge for the emission. Yes, it's for the trailing. And now the only subtle difference that I mentioned, which one of these was keeping the last value? Well, take a guess, it's 50%. No, whether it is audit time or throttle time, which one keeps the last value? Throttle is the one that keeps it. So this is like in the middle and audit doesn't. So this is like at the very end. And now we have like this, the first two. So which one of these would be the bounce time and which one will be audit throttle time with leading emission? Yes, top one is the bounce because as we see here, for example, after 50 milliseconds, we wait for 100 and because there is no emission in between, it emits it. And as we said, throttle, it will emit on the leading edge. So for example, if we take the first interval, 0 is first in that one and that's why it is emitted. And here we see that that's the result. And now again, if we go back to this searching example, we have, let's say, we mentioned the switch map, we mentioned the debounce time, and now we have also the distinct. So again, if we take a look at this first example, we have a group of people, so ordinary objects based with name and age, and now we apply the distinct operator based on the name. What would you expect to be the result of this observable? If we say, yes? Yes, because the third one is considered the same because it compares only by the name. And now if we have like some alternative of this one, we have distinct until changed. And now we say again that the predicate is based on the name. So from the second example, what would we expect to be returned? Yes, that's correct. And what would happen if, for example, I apply distinct until changed on the first example, people 1? Yeah, it will be everything because it compares subsequent pairwise. So John and Jane are different and Jane and John again different. And the last one, we have distinct until key change. So this is like a specialization of the second one. And here again, we say, okay, these are equal based on the first character. So what would we expect to be returned for the third one? Only the first one, yes, because the other two also start with J, so they will be discarded. And now the last two operators of the filtering group is like skip and take. Here I will present the skip. The take is the very opposite of this one. So we have clicks, and based on those also we have the range. And now we use skip 3, which is self-explanatory. So this will just discard the first 3 and emit all the 7 ones. But what would happen if we use skip last? So we would expect, of course, that the first 5 are emitted, but there is one catch here, and that is that the emission of the first will happen once the 6th is emitted from the source observable. So there is a delay between the emission of those. Then if we use skip until, this is like the flavor where we use observable to dictate when this is skipped, and skip while, this uses a predicate, so again, this will start skipping while we have different from 5. There is also one convenient group of operators is that we have in mind that, for example, during this processing, if there is some error, then the stream will be broken and we cannot do anything with it. So we need to have at least some resilience. And in this case, I mean error handling operators, this repeat is just because I needed to group it somewhere. Repeat is basically for the happy case. So this would say that once we perform this call, if this is successful, then we would need to repeat it 3 times, and we need to do this with exponential backoff. More interesting case is this one with the retry. So in this case, we say if there is an error, then again, try to make the call, but insert some time in between. This is like internal counter, so this will try again after 1, then 2, 3 seconds, and so on. Catch error is the operator which basically offers the resilience. So here we can say, let's ignore the error and continue further, but we can also imitate the retry behavior. So this result 3 is basically the equivalence of result 2, and we say that apart from the error, also we have as an argument the observable which was caught with it, and we can again imply our own logic when to throw the error or whether we need just to retry. And here, if we again throw the caught, this will be the same as retry. And now we have multicasting operators, and before talking about that, we need to show some definition, like what is a hot, what is a cold observable. This is like not intuitive at all, because a cold observable would be the one that the creation of the very same value is within the observable itself. And the hot one is the one that the creation is outside, and that's what it helps that when it emits, all of the subscribers would get the same value. How we can make a call observable hot is by applying the share operator. So here is like one example. Here, if you see, we are doing the creation within with math random. We take 3 values and then we have the share operator. This will actually do this caching, similar, for example, with memoization and the pure functions. And then once we subscribe to it, we make sure that even though this math random will always return like a different value, both subscribers will receive the same value. Have in mind that here the delay of 3000 means that the emission is delayed and not the subscription. And now the next question is what happens if we have like multiple subscribers, but not all of those subscribe at the same time. And we would also like to obtain the same behavior. Then we would need to use like a different operator, and that is the share replay. So this is heavily involved in subjects. As we see here, we have set timeout on the subscribe function. And if we do this without a share replay, this would mean that the values that passed until the second one subscribed will be discarded. But if we use share replay, then these are again kept, and once every other subscriber comes, all of the values are emitted. The default behavior is like that, but we can also supply a number argument, and then this would mean like replay the last n emissions, whatever that number is. And now you saw previously that some of the things are deprecated. There were also some warnings or even errors by StackBlitz. So we will start, for example, with combine latest. This is one deprecation that is not really clear to me why this was done, because this previous way would be easier to understand. We have like these three observables and all of them are equal between themselves. So the new way would be to do something like with latest from and use combine latest with. But the thing is that it doesn't matter that this is called on the first one, the result would be the same. Every time any of these emits, you would get the value as array. So we can also interchange timer 2 or timer 3, the result would be the same. Also, we saw this map to operator. So this is mapping to a constant, and the easiest way to replace this is by using actually map, and there we do not provide any argument and we return a constant. And also plug is announced that is to be replaced, and we can again replace it with a map and use this safe navigation operator in between. The syntax is a bit strange, but this would be the way to go after version 8 is on. And the last one is this what we saw with partition. So the reason was that the change here is partition was a pipeable operator and now it's a standalone function. So it's the same name but under different package, and it accepts two arguments. The first one is the observable which you want to partition, and the second one is the predicate. We didn't mention about the retry when operator, but this is something that once we have errors, we can decide how to retry, and we can also change this one. It's actually now an easier way that we need to move everything which was handled into the pipe outside. This is into the map value, and then this delay is just replaced with the retry delay property. And now we have reached the part where we have like a showcase of two games. So the first one would be example of Lotto. So we have like one ticket with 7 numbers, and then we would like actually to simulate the way, for example, that the balls rotate and some of those comes up. We'll do this by basically having random numbers, and we want, once we click on the document, some number to be generated. And this is like the first case, then we are missing an operator here. So I know that we have mentioned like a lot of operators, but could you maybe have a guess which operator is most convenient to use in order to simulate this behavior? So this map is basically just creating random numbers, and we want, once we click on the document, to take the number which was like the latest generated from those. It has to do something with the marble diagram example. Yes, it's actually the sample. So there we just provide the document click and we take that value. And in the tab, as we see here, we have the logic that basically once this number is on, we just remove it from the list. And now what would be the end condition? When do we need like to stop reading values from this observable? So this is again something that we mentioned near the end. One of the yes. So it is take, but because we need to use it with a predicate, which flavor of take it was? Yes. And the use case would be? As you see here, we are removing one number after the other from the Lotto ticket. So the condition would be that once the Lotto ticket becomes empty, this would be the use case. The only thing here is that take until accepts like two arguments. The first one is of course the predicate, and the second one is whether the offending value should be inclusive. And this is something that in this case we would want. So to display like the last value before we end with jackpot. So now if I go to StackBlitz, so here I have the example. And as you see here, the first one is the sample, where the sampler is expectedly this from event click. And the second one is take while, where we have like the Lotto ticket length, if it has any numbers to continue, and then we have true. So here into the console. I think, yeah, it is seen. And now we start clicking and we see the numbers popping up. So once we reach some number which matches one of these, then we will also display the array. When we see here the 16 is present, so now we just console log it, and then this is reduced to 6 numbers. And now we have just to click a bit our way until everything is removed. And as it appears, we aren't very lucky, so this will take a bit of time. And now we have only the 19. And once 19 is off, the array is empty, and then we end up with jackpot. The second one is an example with the game Crack of Code. So I'm supposed every one of you knows this one. We have like 5 symbols. You have 5 tries. Each try you have like 4 positions, and after each try it tells you like how many of the symbols were on the right position or how many are guessed. And now if we try to simulate this, first we have like this observable which would be like 1 try, and here we are listening to keyboard events. We're filtering, of course, the ones which are not between 1 and 5, and now we need an operator to actually emit the combination once we have like the number ready. So which operator would be like most convenient here? We need a combination of 4 symbols before we emit. But the take is it will emit them one by one. We need this like to be outputted as an iterable, as a group. It's again somewhere into the second group of the presentation. Well, again, grammatically, what would make most sense of the operators? What you would need to do in order to gather this before emitting them? No, because there is no condition here. We just need to take them, but we need to accumulate them until it reaches the number. We need to buffer them. So we would use like the buffer count here because that's like the most straightforward. We just apply a 4, and once we have 4 valid values, then we will output them. And the next one is that how we would check for a match. So first, of course, we generate this sequence, and now we take the user input and then we compare it. And in this case, we would really like to use this special operator sequence equal. So this like takes 2 observables and compares whether the values emitted in order are correct. So in this case, because this needs to be an observable, we're using from to convert the array outputted from 1 try into observable. But then we wouldn't like to subscribe twice, so we would like to flatten this. Which operator is missing here? In order to make sure that we will have like only 1 subscription. So this is now shifting a bit to the very beginning of the presentation. Because there we were talking about higher order observables, and we mentioned some methods which under the hood actually handle this 1 subscription for us. This slide with the flavors, with the juices. Yes. Which one would you use here? Yes. Merge map would be the correct one. So this will emit the Boolean as one value instead of observable of Boolean. And now we need somehow to track progress of how many tries did we have. So we would like to emit on every value once the timer is incrementing. So now this is the use case that I mentioned, for example, that in some cases we're mostly introduced into we're most interested into the reduce function, but this time we like really want the emissions of every subsequent decrement. So in this case, we would need to use scan. Yes, we would need to use scan because there we would accumulate, but we want actually to output 1, 2, 3, 4, 5 as it comes. Now for the rest of the logic, we would like actually to have the group of the tries and match together. So this, we have tries counter, and now we would also need to output like a tuple where we have the check for match. So in this case, which operator we would use? So this is the operator that, as we said, one observable is more equal than the others, and we would like to have the latest value with the once this emits the tries counter. So this is again one of the from the more the merrier group. So combine latest was if there is like equivalence between all of this, but if we wanted to actually just take the latest value from others based off when one specifically emit, we would use which one? This is like the with latest from operator, because here we have the tries counter, and now we need to use like with latest from check for match. And then we'll have like a tuple. The first one will be the number of the counter, the second one will be the boolean, whether it is a match or not. And we also need to track, so there is like a given time unit in which this needs to be completed. In our case, it would be like 1 minute. So again, which operator we would need to use that will emit after 1 minute? Yeah, yes, timer, but with how many arguments? Yes, it would be 1, because after that we do not want subsequent emissions, we just want like, so if we want 1 minute, what would be the argument inside? Because it's in milliseconds? Yeah, it's 60,000, yes. So this is like the first part. And now we have like 3 terminal states. The first one is that if we reach like the tries counter, then it's game over. If we have a successful match again, and if a timeout is reached again. Now, which is the most convenient operator that we would need to use in order to make sure that this behavior is kept? So this can end up in either of the 3 ways, but they are mutually exclusive. So this is one of the, not really, because with combined latest you would receive these values with array, and then what you would do with them. Here we just want like to take one of these, subscribe to one of these, and that would be it. This was like the odd one out into the joint creation operators. We mentioned a couple of them, and then we mentioned like the last one, which didn't have much in common with those. It has to do something with Formula 1.
Race.
Yes, here it's the race operator, because this is what we want. Once any of these emits, we just like to subscribe to that one, and the other ones are not of interest. And now we would need to use this inside the game. So here basically we have the compute and render logic, and this needs to end once this emits. And in order to do this, now is something that you also mentioned previously during the Lotto example. Once we reach any of these terminal states, this also needs to terminate. So we will need to use, yes, take until, and then we'll supply like this observable as an argument. But the last thing here is that if you see how this is made, if we have take until here, this would mean that once we have the counter reached, the last row will not be rendered, because simply this will finish. What is the most straightforward way, I'm not saying the best way, in order to make sure that after the counter is reached, we will still first render the user input. Because here the thing is that these two will start at the same time, and the thing is that once this is reached, there won't be a rendering logic, because take until will simply stop the stream. So we need to make sure that this one comes later, and in order to do this, which is like the obvious operator to have. Sorry? Yes, we need to delay it, and in this case we will say, okay, we will delay this one, this will not emit, the game will complete, And after that, there will be a delayed emission, and then we're fine. And now, in order to make sure that this actually works, so I have the second example, and here we already have the first unhappy scenario because I left this open way more than 1 minute. So this is like time's up. And now let's try to crack the code. So tell me some combinations. Oh. Okay, 1 correct place, 2 incorrect. So maybe let's start with this. Okay, now we have worse. I mean, of course, there is one other way we can cheat, because here I have conveniently locked what is the combination. So if I say 3134, then we can be smart, and then we have cracked the code. So the one thing left is just to show off the time counter, and I will just, yes. So if you see here, everything is displayed, and then this would have, you have no more tries left. So these are the 3 terminal cases. And this is more or less what I had to share. So thank you for your attention.